I didn't send it around yet, but that's fine, go ahead and sign it. And then you can pass it on. Okay, is everybody at Nearpod and using this code? So I'm signed in, and you're sitting, or should be, where I am when you get into the lesson. And we've actually already done most of section 1.2, so I'm going to kind of skip through a lot of it. Except I'm going to stop on one problem. We talked about function notation last time. And we said that this is a function called g of x, not g times x, but g of x, is equal to negative 4x plus 5. And we found g of 3 by plugging in 3. And then we found g of 0 by plugging in 0 for the x. And then g of negative 2 by plugging in negative 2. And g of b by just simply replacing x with b. So we found that g of 3 was negative 7, and g of 0 was 5. G of negative 2 was 13, and g of b was negative 4b plus 5, simply plugging in b in place of x. So just as a quick review, given the function, the square root of the quantity 2x squared plus 1, find for me f of negative 2. And all you have to do is type in your answer. Just type f of negative 2 equals. And then your answer will pop up here, and I'll see what you think the answer was. And you can use your calculator. So for the answers I'm seeing are correct. X, W, B, K, N.
K.
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 Sorry. Yes, excuse
So
me.
it'd be written out, like, so intercept them?
No, it's just written out f of negative 2 is. So f parentheses negative 2, close the parentheses, equals, and then tell me what the value is. What's the numerical answer? When you plug in negative 2 into that function, what do you get? And then once you've typed in your answer, you just hit send. And it'll give you a screen that says thank you. You can still see your answer, kind of blurred in behind it. It'll say thank you. I'm still missing a couple of answers from folks. This is not an optional exercise, folks. You have to answer.
Do you still get credit if it's wrong?
Even if it's wrong. Now, there will be times when we'll do a quiz in Nearpod that it will have to be right. But this, we're just learning how to use the quizzes now. There's lots of ways to do quizzes. I have a multiple choice. I can have you actually write something out with, with a pencil that's in the Nearpod, and you have to write with your mouse if you're on the computer, but you can write with your finger if you're on your iPad. And then this one, you're just typing an answer. Are you in, Eddie?
Oh, yeah.
Okay. Okay, here's a correct answer. That's written out the way that it should be, f of -2 in parentheses equals 3. Now, if you just type the number 3, that was okay. Okay, because all you're doing is you're plugging in -2 for x squared, and -2 times -2 is 4, and 2 times 4 is 8, and 8 plus 1 is 9, and then the square root of 9 is 3. Okay? This is the best way to write it, unless I had f of 2 equals and then a blank, and then you just fill in the blank. Okay? So we also talked about supply and demand last time. We filled in some vocabulary about supply and demand. We talked about the law of demand and the law of supply. And we talked about equilibrium point, which is where supply and demand have the same quantity and the same price. And we did this problem all the way through. And at the end, we graphed both of the equations, the supply equation and the demand equation, and we found that those two had the same point in common at the 0.6 and 4.5, meaning that the supply and the demand would have been 6,000 at a price of $4.50. And we also graphed it on the calculator and found the equilibrium point on the calculator. And the last thing we talked about was that before you reach the equilibrium point, there is a supply surplus and a demand shortage. Once you hit the equilibrium point, then the demand actually goes down and the supply goes up. So you have too many supply and the demand isn't there, so you're gonna, that's not good for the manufacturer. People aren't buying it. Before you reach the equilibrium point, that's good for the consumer because they're actually being able to buy things at a lower price, and the manufacturer is trying to catch up. So equilibrium is where supply and demand are same price, same quantity. And we solve that equation algebraically as well, so I'm going to kind of slide right on past that. And we're going to go to something, this is the last problem in this section, it's called cost analysis. So for cost analysis, we're on the middle of page 12 of your notes. The cost of manufacturing an item commonly consists of two parts. The first of the two parts is what's called a fixed cost. The fixed cost covers things like designing your product, setting up the factory, training the workers. It's the cost of doing business that isn't going to change whether you make 1 or 1,000. Those costs are going to be there, and they're going to stay constant. So within some limits, the fixed cost is constant for a particular product, and it doesn't change as you make more and more items, whatever it is you're manufacturing. The second part of the cost, though, is something called a per item cost, and it's referred to as marginal cost. That part of the cost does change as you make more and more of whatever it is that you're manufacturing, because as you make more, it requires more materials, it requires more packaging, it requires more shipping costs, because when you make more, all of those things cost more. So the total value of the second cost does depend on how many items you make, and again, we call that marginal cost. So let's look at an example of marginal cost. Small company decides to produce video games. And the owners find that the fixed cost for creating the game, that means hiring somebody to design it, write the program, and then actually acquire a place to manufacture, so that you're paying rent and utilities and hiring workers to actually manufacture the product. So their fixed cost for creating the game is $5,000. And then after they have actually created the game, it costs $12 per game, per copy of the game, to actually produce the game and distribute it. So we need to find a formula called C of X for the cost of X items. C of X is the cost as a linear function of X, and X is the number of the games that you produce. So first of all, you notice that if you don't make any, you don't make a single item, then it's going to cost you $5,000. That's your upfront cost before you ever make a single copy of the game. So C of 0 then is 5,000. That would be your y-intercept. That's also your fixed cost. Your fixed cost tells you your y-intercept in your equation. C of 1 would be $5,000 plus the cost of producing one game, which is $12. So C of 1 would be $5,012, and C of 2 would be $5,024, and so forth. So basically, the way that you write the cost function is C of X is 5,000 plus 12 times X dollars for X games that are being produced. So your cost function has to have all of those elements. It's not just an equation. It has to be written in function form, not y equals, but C of X equals, or whatever you choose instead of C. We just chose C because it's cost. And then the way that you calculate that cost, with X as the input, and then you actually have to say what C of X is measured in. It's measured in dollars. And then what does X actually measure? And it measures the number of games that you produce. So all those are parts of what's called the cost model. And every time X increases by 1, the cost increases by $12. So $12 is the slope of your cost function. It's the rate of change. It's the cost for each additional game. This cost function happens to be linear. Yes?
Well, I was just going to ask for the code again because I'd rather do it on my computer than on my phone.
Okay, yeah, I can see why you want to do that.
Yeah.
It's X,
Okay.
B, I'm sorry, XWB,
Okay.
K, N.
Okay.
Okay.
Back to that last page for 1 second.
Sure. Do you have a question?
No. Okay.
Okay. So the key thing to remember is when you're writing a cost function, it is an equation. Oops, can't pick that up. It is an equation, but it's more than just an equation. You actually have to include the labels for it to be a model. So in a cost function of the form C of x equals mx plus b, m is the marginal cost, which we also call slope, and b is the fixed cost. So the linear cost function is C of x for producing x items. So let's look at another cost function. The marginal cost to make X batches of a prescription is $10 a batch. And the cost to produce 100 batches is $1,500. Find the cost function. Do we have the fixed cost? Where?
The 1,500.
That's to produce 100 of them. Ah. It says it's $10 per batch. So that's the slope. What are they actually giving us when they say the cost to produce 100 is $1,500? That's giving you a cost for a particular number, which will fit with the slope. If you divide 1,500 by 100, that gives you 15. What do you suppose 15 is? I would think it's, well, it says it's $10 a batch. What we've got here is we've got the marginal cost. What we don't know is we don't know the fixed cost. We know that a cost function is a linear function, y equals mx plus b, or c of x equals mx plus b. We've got the slope. We've got the cost of 100. So 100 is x and 1,500 is the cost. We can find b. We can find the fixed cost. And that's what we're going to do. We take the 1,500, which is the cost of producing 100 of them, is equal to the slope, which is $10 for each one, times 100, because at $1,500 cost, we produced 100 batches, plus B, and the only thing we don't know is B. So we multiply 10 times 100, and that's 1,000. And then we subtract 1,000 from both sides, 1,500 minus 1,000, and we'll have the value of B, and the value of B, it turns out, is $500. So your fixed cost is $500. Your slope is 10. So your cost function is C of x equals 10x plus $500 for producing X batches of the prescription. Okay? It's very much like a problem that we did at the very beginning of the course. You know it's linear. You've got some information. You have to figure out how you use it. You've got a point, xy, or a point, x, c of x. And you've got the marginal cost, which is your slope, so you simply need to find your y-intercept. Okay? Company has fixed costs of $12,500. The cost to produce 1,000 widgets, whatever a widget is $13,260. And widgets, actually, they in economics and manufacturing, they use widgets just as a generic term for something that they're going to manufacture. So we're going to find the cost function C of x and assume that it's linear. Okay, so we have the fixed costs. That tells us what? That tells you B. Fixed cost is B. Then we have the cost to produce 1,000 is $13,260. So that gives us, for a particular value of X widgets, it tells us what C of X is. So that they've given us a point. We need to use that to find the slope this time. This time we have to find the marginal cost. So we take the form of the cost function, which is C of x equals mx plus b. We know that when you produce 1,000 items, which is x, that it costs $13,260. And you know that if you don't make any items, That's your fixed cost. Those are $12,500. So the first thing we want to do is we want to subtract this $12,500 from both sides. And when you subtract 13,260 minus 12,500, you get $760. And that's equal to 1,000 times X. So then you divide both sides by 1,000, and you find out that the marginal cost is just 76 cents. And in order to find N, you could also, incidentally, rather than doing it this way, you got 2 points here, 0, 12,500, and 1,000, 13,260. So you could have taken those 2 points and used your slope formula just as well and come up with the same slope because you're given 2 points.
I don't understand how N became X in the third one down, where it says 760 equals 1,000 X. How did N become X?
It shouldn't have. It should have stayed M. And I don't think I can fix it here.
Okay, I fixed it.
Yeah, it should be, that should be M. I will correct that. That should still be M, not an X. I'll switch over here for just a second. What I'm telling you in the last part, let's see if I can find the example we're working on. In the last part, instead of using the cost formula, we could have taken that we have fixed costs of 12,500, which gives us the point 0, 12,500. And the fact that 100 costs 13,260. And we could have used the slope formula and solved as well. So your slope formula means you take the difference in the y values and the difference in the x values. So using the first point, x is 0, y is 12,500. Here we have x is 1,000 and 13,260, and these could have been interchanged. They didn't have to have this one first and that one second. It could have been the other way around, and that still works. But 12,500 minus 13,260 is negative, and rather than trust my not quite caffeinated enough brain, I'll grab a calculator. So we get negative 1260. And 0 minus 1,000 is negative 1,000. And negative cancels negative, so the slope is actually positive. I'm sorry, I misentered that number. Let me back up. I just realized I left out the 5. So negative 760, not 1260. And then when I divide that by negative 1,000, I still get the 76 cents. Okay? And since your costs are in dollars, then this is 76 hundredths of a dollar or 76 cents. And that's 76 cents per item. So if I give you the information for cost function, and I give you at least two pieces of information. I'm going to either give you the value for a certain number, the cost for a certain number produced, or I have to give you the y-intercept, or I have to give you the slope. I have to give you any two of those three, and then you should be able to come up with the cost function from there. So we good to go on that now? And again, that's our last problem that we'll have to come up with. So the goal of every company now is to make a profit, and here again, we're going to use the same kind of problem. We're going to make a profit. How do you know if you make profit rather than loss? What's the difference in profit and loss?
You're selling your product.
Say it
You're
again.
selling your product.
Okay, you're selling your product, so you get revenue from the product, but if you're selling it and you're losing money, what happens? What has happened that caused you to lose money?
You're not selling anything,
No, you're selling it, but you're losing money. How do you know if you make a profit, which is positive, you're gaining money? What has to happen?
Well, you have to be able to pay all your expenses and leftovers.
And then you have leftover, and the leftover's your profit, right? Okay, so when you pay your expenses, that's your costs. We just talked about cost functions. When you sell your product, you have something called revenue. Revenue is the amount of money that you bring in from selling your product. So your revenue is generally how much you charge for the item times how many you sold. Okay? Whereas your cost is how much it costs you to make those items.
AKA outsourcing.
Yeah. Outsourcing, if you're not, if you're a small business owner and you are the only employee, then of course you're doing all the work and you're getting all the revenue, but you still might not be making any profit. Okay? So the goal is to make a profit, and a company can only make a profit if the revenue, which means your income, what you took in for selling your goods, your revenue has to exceed the cost of producing and selling those goods and services. And the companies use break-even analysis because they want to be sure they at least break even. They don't want to lose money. They prefer to make a profit. So what happens is you have a revenue function, and the revenue function is the amount of money the company receives. It's the product of the price per unit, and that price is P, and it's usually in dollars. And the number of units sold is X. So if you take the price per unit times X units, you'll have the total amount of money that you're bringing in. For example, if I sell paperweights, and I sell them for $2 each, and I sell 5 paperweights, 5 times 2 is $10 revenue. Now, if it costs me $3 to make each one of those, marginal and fixed costs together, if it cost me $3 and I sold 5 of them, then it cost me 3 times 5 or $15 to make the paperweights, and I sold them and I got how much for them? I need to sell them for more than what I paid to make them. So R of X is the price per item times X items. P of X is R of X, your revenue, minus your cost. What did you take in versus what did you have to spend? So the number of units X at which the revenue just equals the cost is called break-even quantity, and it's where R of X is equal to C of X. You can also set profit equal to 0, and that works just as well. And the break-even point is an ordered pair that indicates the point of 0 loss or profit. You're neither making nor losing money. So here's an example of break-even analysis. You have a firm that's producing poultry feed, and they find that their total cost in dollars of producing and selling X units of this feed is 20x plus 900. So it costs them $20 a unit per unit plus a flat cost of 900. And they plan to charge $24 a unit for the feed. So we want to determine, first of all, the revenue function. Second, how many units do they have to sell to break even? And then last, what's the profit for 100 units of feed? And then how many units do they have to make and sell, make and sell, it has to both be true, to have a profit of $900. So we're going to start from here. Now you've got a graph on the next page. I'm going to actually do the problem on the next page, so I'm going to make some notes about my functions, and then I'll show you. Okay, what they've told me is this is what it costs me. Let's see if I can get that a little bit brighter. Is that better? I think that's a lot better. Okay, so here's my cost function. What would my revenue function look like?
R of X equals 24.
That's right, R of X equals 24X, because the problem says they plan to charge $24 per unit of feed. So it says determine the revenue function. There's your revenue function. There's part A. How many units do they have to sell to break even? They will break even if C of X is equal to R of X. So they're going to break even algebraically. We can find it by saying 20x plus 900 is equal to 24x. And if we subtract 20x from both sides, we get 4x is equal to 900. And then if we divide both sides by 4, we'll have that x is equal to 4 goes into 9 2 times, and 1 left over, so 4 goes into 10 2 times with 2 left over, and 4 goes into 20 5 times. So when they make 225 units, they will break even. Okay? Now I think there's a typo, because this is supposed to be 225. I copied that straight out of the book. You would think that would get it right. So this is our break-even point. And the break-even point is at 225 units, and that's where cost and revenue are going to be equal. So let's see, how much would the cost be for 225? We'll use the calculator. Okay, so it cost them $5,400 to make those 225 units. And they sold for $5,400. I think this must be for another problem. Well, no, they've got the right functions. These people really did mess up. You want to change that point on your graph. So part C says, what's the profit for 100 units of feed? Well, for 100 units, your revenue is 24 times 100, which is $2,400. Your cost for that same 100 units is 20 times 100 plus 900, which is 2,000 plus 900, which is $2,900. Revenue minus cost is negative $500. Are they making a profit? Are they making money if they only make and sell 100 units? No, they're losing money. Not a good idea. So then it goes on and says, okay, how many units do they have to sell to make a profit? Keeping in mind here, that they lost money at only 100 units, so hopefully they're going to have to make a lot more. So what they want to do is they want to make a profit of $900. And I'm suspecting I'm going to run out of room here, so let me get another piece of paper. They want to make $900. Okay? But profit is revenue times cost. So from this, I can say I need a $900 positive difference when I take the revenue function, which is 24x, and subtract the cost function, which is 20x plus 900 from it. So using distributive to remove my parentheses, 24x minus 20x, don't forget that's also minus 900, is equal to $900. So if I add 900 to both sides, I'm rid of that. I have $1,800. And 24x minus 20x is 4x. So if I divide both sides by 4, then x turns out to be 1,800 divided by 4. And I'll just be lazy and use the calculator here. 450. So they have to make at least 450 units to make that kind of profit. So here's the answer to part D. To make a profit of $900, they must make and sell 450 units of the poultry feed. And that's what I would expect to see on your test paper or your quiz paper. I didn't ask you what X was, okay? It's nice that you tell me X is 450. That didn't answer the question. The answer to the question is that to make a profit of $900, they must make and sell 450 units of the poultry feed. Okay? And that's going to be true all the way through this course and all the way through calculus. because you're in an applied math class, so we're not just solving equations just for the heck of it. We actually have to apply it to something. Any questions so far? I just figured out what the problem was. When I went to the second slide, they started out with 20x plus 900, and then they changed it to 100 in the next step. So our answer's right for the original problem. In the work that I got out of the book, I didn't notice that they had swapped out that 100. At least we know now where the 25 and 500 came from. So it looks like I'll have to be correcting this one too. So let's go back to the Nearpod for a minute. And I gave you one. It says use your graphing calculator to solve the problem. This is the supply and demand function. Now, I didn't tell you how to use your graphing calculator. How you use it's up to you. You can use it just to do the arithmetic. You can use it to draw a graph. So what you want to do is you want to find the equilibrium point, which is the equilibrium quantity and the equilibrium price. This one's actually a draw it. So what you could do is get your calculator. Help you out a little bit on this one. And go to your y equals menu and enter in your supply function. And your demand function. Using X in place of Q for the quantity. And our window probably doesn't need to go negative, so set the window so that you're starting at 0, and we'll start out just going to 10. And if we need to, we'll expand it. So you can't sell negative, and you can't have negative supply or demand. And I'll look at the graph, and I see there's the first one and there's the second one. So going to 10 was actually way too much. I'll get a little better sketch if I only go to about 5. This one? Yeah. I'm just going from 0 to 5 for both. Yes. Okay. When you hit your y equals, if you see plot 1, 2, or 3 at the top with a black box over it, put your cursor on that plot, press enter to turn it off. That way it won't interfere with your graph. Okay, did everybody get a graph? Okay, before we go any further, remember we're going to have to answer this question on here. And the first few, and I'm going to work with you so that you can see how to do this. Now, if you're on your iPad, you can draw with your finger. I'm on the computer, you can still draw. What you have to do, and I'm going to have to get this over here out of the way, is I'm going to go down here and choose the pencil. You can change how big a point you want your pencil to have by sliding the slider up and down. You can change the color of your pencil just by picking a different color. Okay? So I want my pencil to be blue, and I'm going to make it a little finer point because I don't want to see, you know, like a highway. I just want a line. So I'm going to try to sketch the graph. So I shrunk my screen down a little bit, and to draw my graph, and again, I'm not looking for perfection. Remember, Q is the X, so this is the Q axis. And this is the P axis, which is both S of Q and D of Q. And so here is your demand function. And here's your supply function. And then what I need to find is that point right there. Okay? Because that's going to be the answer to B. So I'm going to come over here and I'm going to hit second, trace, go down and choose number 5, which says intersect. And then I'm going to hit enter 3 times. And it says the intersection point is 1.12, let's call it. And 0.964 would round to 0.96.
What did you put for X equals?
I didn't put anything for X equals. Hit second, trace, and choose number 5. And then hit enter 3 times. Now, since this says that P is the price per pound and Q is in thousands, actually I'm going to change my answer a little bit. So here's the eraser. So I'm going to round that to 1.118. And part of the reason I'm doing some of the things I'm doing isn't just because this is the right way to do the problem. I'm trying to show you the different ways that you have to enter your answers. So Q is in thousands of pounds and P is the price per pound, and that's going to be in dollars. So I'm going to leave that like that. So there's my graph. And then what I know from my graph is that equilibrium tells me this: supply equals demand, since this is 1.118 thousand, that's 1,118 pounds. Are supplied and demanded And I'm gonna abbreviate because I'm gonna run out of room. At a price of 96 cents per pound. And now that I've taken forever to do that, what I didn't tell you is you can also type on this screen. If you go down here to where the little T at the bottom is for the text, I can also get a text box and move it around and use the text box to answer my question. So I could have typed in that text box up there instead. So it's just whichever one you want to do. Okay? What I like about doing this kind of problem and doing Nearpod is I can stop and let you work a problem and me see how you're working the problem without me having to call anybody up to the board, without me having to go around and look at everybody's paper, because once you hit submit, and I'm going to go ahead and tell it to send my answer, once you tell it to send, I can see your answer up here on my iPad. So there's mine, but I can show anybody else's. Okay, I think Eddie's not done, but, or wait, that's not Eddie, I'm sorry. This person may or may not be done, but you know, I can see their work and I know they're doing okay. Okay? And notice that you can't see whose paper you're looking at. I can from right here, but you can't see the name of the person that submitted that. So here's somebody else's. So I can see, you know, that they worked on it. And yes, I sympathize. It's very hard to write with a mouse or your finger. That was a good graph. I have to share it. So here's a good one. Okay? Oops. Your answer should still be there. You shouldn't have lost it.
Yeah, mine's wondering about it.
I can still
Send it yet.
Okay, oh, I'm sorry. Well, that's the bad thing about it, is if I touch it in the wrong place, it sends it backwards and you lose your work. So I try not to put my hands on it while y'all are working so that I don't accidentally lose your work.
So we need to do it again.
No, today we were just playing. Okay, and that actually is the end of that section. Okay? So you have finished section 1.1 and 1.2. And I'm going to leave the presentation. So what we're going to talk about in this last section of chapter 1 is the least squares line. And before I get going, I'm going to see if I do have anybody in here that might be partially expert in this. Who's had problem stacks? Do you remember chapter 10, linear regression, at all?
Yeah.
A little bit?
I took business statistics.
Okay. You'll probably remember some of this as we get into it. It depends a lot on whether your teacher started doing chapter 10 early in the course and used it throughout, or if they did it that last 2 days of class and it just went like, and I never know which one that might be. And people that take this course don't necessarily already have had their statistics course. So I'm going to proceed as if you know nothing. But And usually that's a pretty fair assumption, even if you've seen it before, because if you have seen it, you may have forgotten it. So we're going to proceed as if you don't know anything about how to do this. So, this table, which you have in your notes, lists the number of accidental deaths per 1,000 people in the United States through the past century. And this actually is real data from the National Center for Health Statistics. If you were a manager at an insurance company, these data could be important, because the managers of insurance companies look at data and analyze data to set insurance rates. And in fact, y'all are going into business. If you want to be paid the absolute best that anybody in any business ever gets paid, you don't want to be a business manager. You don't want to be a human resources manager. You don't necessarily want to be an accountant. You want to be an actuary. Actuaries start out making six-figure salaries right out of the box. But it requires a degree in statistics, because what they do is they analyze data and use that data to set insurance rates for various things. So it's an interesting job, but it's not a job for somebody that's a people person, because you sit in your windowless little office and do math all day. You might need to make predictions about how much you're going to pay out next year in accidental death benefits if you're the manager. So even a tentative prediction is better than no prediction at all. So what we're going to do is we're going to take this data and we're going to calculate something called the least squares line. Now I want you to follow along carefully with how I do this, because it'll make your life easier later on. Get your calculator. Turn it on. Press your Y equals button and hit clear. Get everything off of the Y equals screen. Make sure there's nothing whatsoever on the Y equals screen to start with. We want to start fresh. Okay? Then I want you to hit your stat button. And I want you to choose edit. Now you may not see what I see, so I need to ask some questions here. Do you see list 1 and list 2? Are they empty? No? Okay, there is a long way and a short way to empty them out. The bad news about the short way is that if you do it wrong, you hit one wrong key, your list disappears and you panic. So I'm going to show you the long way, and then later on I'll show you the short way when it's not likely to cause you to panic on a test. So the long way is just to simply hit your delete button over and over and over and over and over till it all goes away. Usually there's not that much there anyway, so. And then go to the other list and just hit your delete button over and over and over and over and over until it all goes away. Okay? Now, we don't want to enter 1920, 1930, 1940, 1950, and so forth, because that's going to make our y-intercept, it's going to exaggerate all the numbers and make it harder to find the graph that we want to find. So what we're going to do is I'm going to do something called scale the data. And when I say I'm going to scale the data, this is what I'm going to do. Rather than use the year itself, for X in this particular case, I'm going to use how many years after 1900. Okay? That's what X represents. It doesn't represent the year itself. It represents the number of years that have passed since 1900. So my first X value is actually 20. And my second one is 30. My third one is 40, then 50, 60, 70, 80, 90. And at 2000, that's 100. And 2010, it's 110. So those are my X's. And I'm going to put those X's into list 1 on the calculator. these are my, let's see, death rate. So D of X, the death rate in X years after 2000. And these values are going to go into list 2 of my calculator. And I'm going to come up with an equation to be able to answer this question. What do we predict the accidental death rate to be in 2020? And in 2020, X is going to be 120 because it'll be 120 years since 1900. Okay? So here we go. In list 1, I'm going to enter 20, 30, 40, 50, 60, 70, 80, 90, 100, and 110. And then I'm going to enter the death rates in list 2. Make sure that list 1 and list 2 have the same number of entries. They're the same length. Your calculator will give you an error called a dim mismatch, which means the dimensions of the two lists don't match if you don't do that. Okay? And we only got about 1 minute left, so we're going to have to come back to this. But I'm going to leave all this stuff in here. What we're going to do to come up with the equation is we're going to hit Stat and right arrow to Calc. Go down and choose number 4, which is linear regression. Hit enter. And for now, we're just going to do it the short way. So I'm going to go second 1 to get list 1. That's my X values. Enter a comma. Second 2. Tell it that's where my Y values are. And normally I put a couple of more steps in there, but I'm not going to this time. I'll show you those next time because we're short on time. Hit enter. The equation that describes this relationship is Y equals negative 0.50558 times X plus 87.8824. And what we'll do next time is we'll plug in X equals 120 to make the prediction. Okay? But for now, we're done.
This is the, do you have the, your plot codes,
Yeah, let me generate those right quick. If you've got a minute. I'm going to write them down so I can put them in D2L too. The code to go back into section 1.2 is X, G, E, Q, S.
Thank you.
And then let me go back to and do one for 1.3 so you can,
That's for what now?
This is to be able to go in for student pace lessons back to Nearpod and let you go through the slides at your own pace. So the one for the lesson we're on right now is JQ ROV. RO. Jacqueline, Quentin, Robert, Oliver, Virgil. Okay? And I will put those up in D2L. And those will be good the rest of the semester. You can always go back and review them because I'll